purpose of this video is to discuss briefly how to select a good topic for your IB internal assessment for mathematics, the mathematics exploration. So I gave you a couple of pointers here for choosing a topic. First of all, going with a theme that we've discussed already of making it yours. One thing that you need to really make sure that you do is to choose something related to a passion of yours. Whatever you are interested in, highly interested in your life, chances are there's some element of mathematics involved, and that's where you could really capitalize on an opportunity to explore something that you're passionate about and explore the math that is behind it. Another thing that is really helpful when you're choosing a topic, whether you're choosing to start with the passion of yours and then find the math that goes with it, or whether you start with the math and then relate it to something in your life, either way, the mathematics that's involved should be something that either you already understand pretty well, so you can really get into the application and the exploration of it, or something that you really want to understand better. And that, I say that because if you don't understand it well already, you're going to have to do some research. You're going to have to do the hard work of researching the topic and gaining that deeper understanding. Basically, by the time you're done with this project, you should be kind of an expert on the mathematics related to your topic. Now, given that we just finished the Pre-Calc Honors review project, maybe you would use the topic, the mathematical topic that you reviewed, and then look for applications that relate to your life there. That's just one thought, but could be something where you've already done a little bit of work towards this. One guideline, and we'll see this as we look at examples of bad IAs, is if you're going to choose a topic related to something most people are not familiar with, whether it's a game or a concept or something like that, make sure that it is simple enough to explain in a paragraph or two. Now, I'm not talking about the mathematics. The mathematics could be more complex and need greater explanation. What I'm talking about is that thing that you're involved with. And I think this will become clearer as we look at some examples. So let's actually take a look. I've created a little spreadsheet here, and you can, I'm not going to go through every one of these here, but you could pause the video and look at the specific topics more carefully. But I have kind of the good idea and bad idea. And since we were just discussing this, let's talk about some of the bad ideas of ones that were just too complex. One that I've seen a couple of people try to do, not from my own class, but from ones that I was moderating, was Pokemon. This is a very complicated game, and unless you really hone in on just one aspect of the game, you really can't explain it quick enough to the point where it's not going to just monopolize your whole paper. Most people don't know how the card game itself is actually played, so if you were going to look at the probabilities, for example, then you would need to explain it quite a bit. And like I said, unless you honed in on just one small example from it, that would take up way too much space. For example, one of the papers I moderated was about 18 pages long, which is way too long for your math IA anyways. But on top of that, they spent a good 3/4 of that time just trying to explain the game and really never even dealt with the math. Okay, another example that I've kind of found to be a bad example is card counting. It's kind of a popular one because people think of, oh, I can win at blackjack or whatever. So far, I've seen 3 attempts at this, 2 of my own students and one I moderated. So far, we're 0 for 3 on just getting to the level of complexity that would qualify for SL math. However, if you really get too far into the different card counting systems, it gets very complex. So this is one of those ones that, finding that happy medium of being on the level with the math, but not getting too complex is very, very difficult. If you want to do something similar to this, as far as the probabilities go, this is what's known as conditional probability or Bayes' theorem. There are other applications of that mathematics that you could do that would be easier to keep within the level of complexity that you're looking for. Another one is looking at Sudoku. Now there's another example of this that I saw a student do that was not on probabilities, and they did a fantastic job, and we'll take a look at that in a second. Looking at the probabilities of Sudoku gets very, very complex because of all the different possibilities. So I would shy away from that one, even though it's kind of a popular idea that students have. Another one is Pythagorean Triples, just exploring that idea. That by itself, the Pythagorean Theorem, is not IBSL level. That's prior learning. You pick that up in pre-algebra probably. So unless you are doing something much more advanced with those triples, that's not going to be the level. Okay, so let's look at good ideas. Okay, there are different things involved with the chi-squared or Spearman rank testing. These are not in the SL syllabus, however, they would be on level. Correlation with Pearson's R, that certainly would be. SIR diagrams, this is symptom, infectious, and recovering. These are modeled for modeling outbreaks. And it's actually a logistic regression problem. You can do curve fitting, you could talk about exponential models and then get into a logistic model. And that might be an interesting idea. Something as simple as exponential growth and decay or compound interest is technically part of the SL curriculum. I would go very deep into the explanation of what's going on, but for example, one student did one on, is college worth it? Doing a cost analysis of going to college versus entering the workforce, and the difference in, the average salaries and that sort of thing. It's kind of interesting there. Fibonacci sequence, there's a number of different things here that could be done. Zeno's dichotomy paradox is an interesting one for geometric sequences. There are ones for integral calculus, so those of you who are coming from calculus honors, maybe you want to do something with calculus. Basically anything involving calculus will definitely be on SL level, so that would be good. Those of you I had for pre-calc honors last year, we did the little enrichment project on encryption with matrices. That's the kind of thing, exploring that, obviously doing way more than what we did in class, would be an interesting exploration as well. Permutations and probability. Polynomials, I saw one student design a roller coaster using polynomial functions and finding intersections. A lot of different possible correlations, regression and curve fitting, here to population projections, a number of other things. Here's the one I was talking about before too. Sudoku, they use set theory, and obviously that's not in the SL curriculum, but it's not terribly difficult, and the one that I read, they actually did a very good job on this. Another real interesting one I thought was applying trigonometry to World War II armor for tanks. And I wouldn't recommend doing that exact topic, but seeing how people have, maybe the military even have used angular things with vectors and trigonometry to maybe first design stealth aircraft or whatnot. Be kind of interesting. And then there's some other things here as well that you could do. You know, a volume of a solid made of multiple functions revolved around the x-axis. So that's one of the last calculus topics covered in the syllabus, but it really is not that difficult. And here's where, you know, you could create some shape that you wanted to make and ensure that it had a certain volume and explore that idea. So these are some ideas, but remember, as you're coming up with an idea, don't just think about something you're passionate about, and don't just think about a mathematics topic. Try to see if there's anything that you're passionate about and a math topic that you're interested in that kind of intersect somewhere. So these are just a few ideas. Certainly, I'm not expecting you to just pick one of these specific ones necessarily, but get creative, and at this point try to come up with at least 2 ideas that you can do some preliminary research on, and either narrow it down or pick one of them to go with eventually. But I think 2 to kind of do some research on would be good. So you can click on the form, and I want you to record what those are, what your 2 are that you're going to do some further searching on, and then we'll talk about which one you're actually picking in the future here. Okay, before we go, I do want to look at one other thing here, and just to show you in the folder the things that you download to your iPads. There is this internal assessment details that has a little more of an introduction. It has the rubric on there, but also another thing here, the IA rubric with additional notes and guidance. This is going to be really helpful, and I would say this is probably the document you're going to refer back to the most. Okay, I have some things highlighted, but there are these additional notes related to the different things in each criteria for how it's graded or how it's marked, and I think this is really, really helpful. I used this when I was moderating IAs last spring, and I think it'll be helpful for you. Alright, so go ahead and you can start brainstorming on different topics and see what you come up with. Alright, see you later.